This video covers the Spring Final Review Part 2, or Day 2, pages 4 through 7. So if you need the beginning, that's on a different video. This is the second half of the review. This starts out with cubed functions. So cubed functions are the one that snake up the graph and look like this. We use a midpoint instead of a vertex, and my pattern is 1, 1, 1, 1. We go to the right and up. I guess technically negative, negative, but remember with these, there's kind of a couple different points that we look at, but we're really only focused on the middle points. So my midpoint is just like my vertex. It's the opposite of what's inside with x, the same as what follows. For these, domain and range are all real, so you can do the double R across. My midpoint is at -5. This is positive, so I go up and right, down and left. And then I just make sure I draw kind of a snaky shape. Remember, you will have a graphing calculator for this, so in y equals, you can type in exactly what you're seeing. We have x plus 5 raised to the 3, and if I click graph, it will show me it goes up, snakes, and then keeps going. I'm not going to show you all of them in the calculator, just reminding you that you can use it. So midpoint is opposite, same. Domain and range are all reals. So -2, -6. This one has a negative in front, so we go right and down, left and up, and then we make sure we draw it going up and down. The reason I say up and down is because the cube root looks just the same but goes side to side, so make sure this one goes up and down your graph. Midpoint is opposite, same. So 4, 1. This has a negative in front, so we go down and right, up and left. And midpoint on 14 is 1, 6. Domain and range are all real. So 1, 6. And this one is positive, so we go right and up, left and down. Now, on this page, we have cube root. So remember, cube root is very similar to cubic. It snakes up the graph, but it goes side to side. We still have a midpoint, so that's why I was saying earlier on cube, make sure you're going up and down, because the cube root goes in the same directions, because a cube, or the root, goes like side to side. So this also goes side to side. Domain and range, thankfully for these, are still all real, so we just need to focus on the midpoint and the drawing. So the midpoint is opposite, same. So we go to -2, -6. This one has a negative in front. So we go down and right, up and left, but then we draw it side to side. So really the only difference in these is what it looks like. So you have to make sure you know how to draw them, because both of them have the same pattern, but one goes up and down and one goes side to side. Again, you can plug into y equals to see that. So like problem 16, if you go math, scroll down to 4 and enter, we have x minus 4 under the cube root and then a +1 afterwards. And it'll show you what your graph looks like and help you remember that it goes side to side. So my midpoint is at 4, 1. Domain and range are all reals. So I go to 4, 1. And this one is positive, so I go up and right, down and left, and then make sure my drawing is side to side. Problem 17, midpoint is opposite, same. So 1, -6. And this one has a negative in front, so I go down and right, up and left. (28) is opposite, same. So -3, -3. And this one does not have a negative, so I go up and right, down and left. And again, just make sure on the cube root that it looks in the same horizontal method as the root in the problem. So still using cube root, they want me to now write them and draw them. So to go to the left, we're going to add 4 under the cube root, and then down 3 is a -3. opposite, same. So I go to -4, -3, and then up one, right one, down one, left one, because it's a root, so it needs to go side to side. So I gotta make sure it looks right. 19, up and right, so right is a minus under the cube root, up is a plus after, opposite, same. And it does not reflect, so we go right and up, left and down. 20 reflects. Left is a plus under the cube root, and up is plus after the cube root. Opposite, same. So -2, 4, and then it has a negative in front, so we go down and right, up and left. And still looking at cube root, they really like this cube root. We want to know where it moves. So here is my midpoint. Remember, it's easiest if you define your midpoint first. So this goes right 4, up 2. We don't worry about stretch or shrink, and this one is positive because as you go left to right on the graph goes up. So cube root, it goes to the right 4 and up 2. Midpoint is 4, 2. Domain and range are still all reals. Problem 22, my midpoint has shifted left 4 and down 2. We're not worried about this. This is still positive. So to go left, we add 4 under the cube root, and down we subtract afterwards. Domain and range are still all reals. And then 23, we go right 1 and up 5. Not worried about that, but this one is a negative. As we read from left to right, it goes down. So we need a negative in front. Right 1 is going to be a -1 under the cube root, and then +5 to go up 5. Opposite, same. And domain and range. A quick thing, remember that if you write your midpoint from your function, you can see if your function is correct by going to the 0.15 and making sure your midpoint is there. So if you kind of ignore the graph when you write the function, write your midpoint from your function, and then check to make sure your midpoint matches your function, you'll be a little better off because it's kind of doing the checking work for you.